Okay, guys, we are going to do this in little pieces. So we got three more videos here. Video one that we're going to be dealing with is going to be these trigonometric equations. Now, here's the thing. I do not have the space to do that work there. So what I'm going to do is we will do this work right down here. Okay, so what we got to remember right now is when we're solving for theta for any of these things, we're looking for the interval between 0 and 2 pi. That's for theta. Now, I'm going to start before we do anything else and do a little bit of thinking. So right now, I had said in class when we're solving for this, anytime that you've got something that's solved straight up just for theta, as it's written in the problem, we don't have to do any of the substitutions because you know how we did those alpha substitutions in class. That's something we could do. For any problem like A, B, C, or D, you'll notice that what I have here is just a theta. There's nothing in front of that at all. None of these are going to need to have any substitutions to solve. You look at both of these, however, we actually have something in front of the theta. So for us to solve this, we're going to have to do a little bit of work. Now, what I'm going to do, you're basically working on your understanding and your knowledge of the unit circle. So when I do this, I'll write our first problem here. So problem A is going to be that 2 cosine theta is equal to -1. Now, first thing that I want to do when I'm solving this, I want to get this to the point where I've got just the cosine by itself so I can start to figure out where things are going to be at. So, I mean, you guys have done plenty of this. I'm going to divide both sides by 2 to get rid of my coefficient. This is going to cancel out, and I'm going to get the cosine of theta is equal to -1/2. All right, these are straightforward and easy. Once you've got it set up like that, you just have to think about where on the unit circle is equal to that. Now we're looking at between 0 and 2 pi, so one full rotation around the circle. Cosine is equal to -1/2 in the second and the third quadrant. So when I'm looking at this, my two values that I'm going to have for theta will be 2 pi over 3 and 4 pi over 3. Those are the two values that we have for this. Don't have to do anything else because in the case of something like this, those are the only values on one rotation through the unit circle. So I'm good to go. That's what we're doing. We're solving these values. You basically isolate the sine, cosine, tangent, whatever function, and then work your way backwards to say, where is this on the unit circle? Okay. All right. Problem B. Let's see what we have for this one. B has a sine squared. Now that actually is something we're going to have to think a little bit about what we're going to be doing when we solve it. Doesn't mean we're going to do anything extraordinarily different here. It just means we need to think about what types of answers we are going to get. Now, we don't have a number in front that we have to move over to the other side. So in this case, all I have to do is get rid of that squared to find where my values are going to be. So to do that, we're going to take the square root of both sides. Okay, square root here, square root here. Totally fine. And that shouldn't be too difficult to do. The one thing you have to remember, though, is that when you're solving this will now be sine of theta. And what I'm going to do, because I took a square root of both sides, this is squared. I have a positive and a negative possible result. Square root of the 1 on the top gives us a 1 there. Square root of 4 on the bottom gives us a 2 here. So I am finding the values within one rotation where the sine of theta is equal to either positive or -1/2. Because I took the square root, I've got to use all of those possible answers. So sine of theta is going to equal a +1/2 in our first and our second quadrants. And that would be at pi over 6 and 5 pi over 6. It will equal -1/2 in the third and the fourth quadrants, and that will be at 7 pi over 6 and 11 pi over 6. And this is something you can use your unit circle to be able to find. It, again, helps us out with this. The positive is this set of 2. The negative is this set of 2. Okay. Now we're going to get to see, and I really kind of like a problem like this one because it involves a couple different steps to get you to your answer. Problem C that we have from up here is the square root of 3 times the secant of theta minus 2 is equal to 0. All right, look, you're going to see crap like this, right? Where you've got a bunch of stuff with the function itself. Anytime you have it, you want to isolate whatever your trig function is, get all the other crap on the other side, and then see what we can do from there. So here, to do that, first thing I'm going to do is add that 2 to both sides, and that is going to give me root 3 secant of theta is equal to 2. Then I'm going to divide both sides by the square root of 3, and I am going to get that the secant of theta is equal to 2 over the square root of 3. Now listen, if you are anything like me and you get a problem like this, the first thing you're going to think to do is rationalize the denominator, because of course that's what you're going to want to do. You got a square root of 3 on the bottom and you don't want to do that. But we don't really have the values of the secant memorized. We do have the values of its reciprocal memorized. Secant is the reciprocal of cosine. So if I take the reciprocal of both of these sides, my left-hand side then becomes the cosine of theta, and the reciprocal of this side is just square root of 3 over 2. That's why I didn't want to deal with the rationalization, because that is a value I can deal with. And if I'm going to flip it, I would have to rationalize it again and simplify it. Now, here, we're just figuring out what thetas give us square root of 3 over 2. Well, it's positive, so that would be in the first or the fourth quadrant. And the values that are going to give theta the square root of 3 over, or give me cosine, the square root of 3 over 2, is going to be at, let's think, cosine's the x, that will be at pi over 6 in the first quadrant and 11 pi over 6 in the fourth quadrant. So that gives us our two positive values and where we had to go for this one. Okay, so we now have how many left? I got a bunch of crap on my desk. I got to move out of the way so we can actually keep working. Okay, I have got D, E, and F. D is a little bit more involved, but not terribly so. D, we are going to be dealing with -4 sine squared theta plus 3 is equal to 2. Again, it's just set up in such a way that we're supposed to solve it. It should be fine. It's squared, so I know I'm going to have to take the square root. So you got to keep in mind that plus or minus, but let's get to moving some things. -3, -3. Now we're going to have -4 sine squared theta is going to equal -1. That's fortunate. Okay, and then I'm going to divide both sides by -4. That'll cancel. And I am going to get sine squared theta is equal to 1/4. Now, y'all, I don't know if you look up there, problem B, but it's literally exactly the same thing that we just did. So that's fine. I'm going to have to take the square root of both sides to solve it. When I do this, here's the one thing that I do want to make sure we talk about, because sometimes I gloss over this stuff. This means I take the square root of the top and the square root of the bottom. It is a plus or minus. But when I do that, square root of 1 is going to be 1. Square root of 4 is going to be 2. We'll have plus or minus a half, and I'm still looking for the sine of theta to equal that. And guys, it's the same answer that I had before, because it's positive and the -1. Theta is going to equal pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6, just like it was before. It's possible you're going to have a square root of 3 over 2 when you do something like that. It would be really easy for us to set it up. This is not an example for a problem, but because we had the same one, I'm just going to show you. If I had something that was like cosine squared theta equals 3/4, then if I take the square root of that for both sides, that would be something like cosine theta equals √3 over 2 with a plus or minus, and then we would have to solve that. Now, again, that's just showing you that sometimes they will simplify like this and become a 1, but sometimes you'll have to leave it as a radical and figure out where that's going to be at 2. Or if it was a square root of 2 over 2, that might be something we'd be able to do as well. Okay, with that being said, I'm assuming y'all are good. So let's move on to these problems with the things and our theta. So let's do E first. E is the cosine of 2 theta is equal to -1. Okay, so our first thing that we're going to do is we're going to do a sub it. We're going to say that alpha is equal to 2 theta. And I'm going to rewrite this as the cosine of alpha is equal to -1. Now, we're going to go through, we're going to look at this and figure out then where on the unit circle we can figure out that this is going to be -1. Now, the nice thing is the cosine itself is only equal to -1 at one place on the unit circle, and that is at pi. But because we had to do a substitution, and anytime you have to do a substitution like this, we have to include the possibility that when we sub back in, there are more answers. So I'm going to put in here the 2k pi part of this to say, hey, there could be more stuff. Let's figure out where this might be. All right. So with that being said, this is my answer for if it's the alpha. So now I'm going to bring this back and sub back in. For 2 theta is equal to this thing that we just solved for. Okay, So I know that that's the case. Again, I am solving this for theta. So I have to do a little bit more work here. I know that 2 theta is equal to pi plus any rotations that I could find. To solve this, I am going to have to divide both sides of this equation, means everything, by 2. That is now going to give us that theta is equal to pi over 2 plus the 2's will cancel, k pi. The reason why it's important for us to do this is because I may have more than one answer within my I have to think, my interval that I'm going to be using for theta. I know that theta has to fall between 0 and 2 pi. So when I've done this, I'm going to start plugging in k values and seeing which answers falls in that category. So the first one I start with is k is equal to 0. That one's pretty easy because that just falls off. So if k is equal to 0, I know that theta is just pi over 2. That is one answer that would totally work. If k is equal to 1, theta is going to equal pi over 2 plus pi, or 3 pi over 2. Now, if I put another one in there, I'm going to be adding another pi. This is already almost at the end. So the only 2 answers that I could possibly have are pi over 2 and 3 pi over 2. If you want to check it, k equals 2 equals theta is pi over 2 plus 2 pi. I'm already over a rotation here, so that is the reason why this does not work. And that's what you've got to do for all of these. So in this case, we've got 2 answers because we've got this in terms of 2 theta. And that's kind of a way to think about it as well. Whatever your coefficient is there, generally you'll have about that many answers. Now, I'm not going to say it's always that way, but it is that way most. All right, last problem. We end up with our F. And so let's hope that's nobody's grade when you get done with this final. Wasn't that a funny, like, dad math joke? You know, it's not designed to invoke fear, I'm sure. Okay, so there we go. Sine of 4 theta is equal to 0. We are going to do a sub with alpha is equal to 4 theta. And we are going to then say that the sine of alpha is equal to 0. Now, in the case of this, there is more than one place where the sine value is equal to 0. Alpha could be 0, or alpha could be at pi. Both of those are values where sine is equal to 0. So with that being said, I do have to check for additional rotations. I'm going to put for both of these 2k pi because I've got to sub back in. Now, because I'm subbing back in a 4 theta, it is likely that I'm going to have 4 answers in each of these categories. Now, that doesn't mean it's always like that, but it's something that we can look for here. So 4 theta is equal to, in this case, 0 plus 2k pi, and in this case, pi plus 2k pi. Okay, so now to solve for both of these thetas, I got to divide everything by 4. And let's do some simplification. In this case, theta is going to equal 0 plus k pi over 2. And in this case, theta is going to equal pi over 4 plus k pi over 2. Okay. Now, again, we want theta to be between 0 and 2 pi. So I'm just going to start plugging in k values, starting with k equals 0. K equals 0. I've got my 2 values. Theta equals 0. Theta equals pi over 4. Okay, first pair. Now, k equals 1. So now I'm doing this as 0 plus 1 pi over 2. That is pi over 2. And this one is going to be theta is equal to pi over 4 plus 1 pi over 2. If I do that, this is 2 pi over 4 plus pi over 4. This would give me 3 pi over 4. So right now, I got a total of 2 answers here, 2 answers here. We're just going to keep on keeping on. K equals 2 is the next one I'm plugging in. So theta is going to equal 0 plus 2 pi over 2. 2 pi over 2 is just pi. So there's that. Then in this case, theta is going to equal pi over 4 plus 2 pi over 2. So pi over 4 plus pi is going to be 5 pi over 4. Again, I've got a total right now of, well, let's see, there's 3 answers and 3 answers. Now we're going to do k equals 3. Theta equals 0 plus 3 pi over 2. That's going to give me 3 pi over 2. Theta is going to equal pi over 4 plus 3 pi over 2. Okay, so this is 6 pi over 2, 6 pi over 4 plus 1 pi over 4 is 7 pi over 4. All of these are still within the rotation. Then if I plug in k is equal to 4, theta is going to equal 0 plus 4 pi over 2, which is 2 pi. We know it can't equal that, so I found my first one that doesn't work. These are all of my answers. So my answers will be 0, pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4, 3 pi over 2, and 7 pi over 4. Now that is a crap load of answers for the same problem. But again, what you're basically doing is for every value you get for alpha, you're going to have whatever that multiplier is, that's how many answers you're going to have for that. So in this case, we had 4 values for the first one, 4 values for the second. So a total of 8 answers. Okay, that is all you could possibly want to know about solving equations. So that should be enough. And I will stop the sharing and stop the recording.